You ask a complex question, tap that send button, and within a few heartbeats, a detailed, helpful answer appears. It's easy to feel like the computer is actually thinking through your problem right there in the moment. But that isn't what's happening. The actual work of figuring out the answer finished months before you ever typed a single word. And artificial intelligence's life is split into two completely separate chapters. There is the long, slow process of building the machine, and then the lightning-fast moment when you actually use the machine. Most people assume these two things happen at the same time, but confusing them makes it almost impossible to understand how AI really works. To see why an AI can be incredibly smart about history, but completely oblivious to what is happening in the world today, you have to understand that it simply does not think in real time. The first chapter is the training phase. Imagine a student locked in a giant library for years, reading millions of books just to learn how human language and patterns work. It learns through constant trial and error. The computer makes a guess, checks it against the right answer, sees it got it wrong, represented by this red flash, and then adjusts its internal settings until it gets a green light. This adjustment process is a massive correction loop. It happens billions of times, allowing the machine to slowly learn from its mistakes until its guesses become highly accurate. This stage is exhausting for the hardware. It requires warehouse-sized buildings full of supercomputers running at maximum power for months on end. This diagram of a machine learning project lifecycle shows exactly where this happens. The highlighted blue box in the middle is the model training step, where all that heavy studying occurs. While this is happening, the AI is completely unavailable to the public. It's still under construction, and it can't answer any of your questions yet. Training isn't about being helpful. It's the slow, expensive grind of teaching a computer the rules of our world. Once the studying is done, the student finally graduates and enters the workforce. This is the second chapter, the inference phase. This same workflow diagram shows the shift to the blue model deployment phase at the very end. The AI is now out in the world, ready to be used. When you type a prompt into an app, the AI is no longer learning or updating its knowledge. Its memory is essentially frozen in place. Instead of checking its work or correcting itself, the AI performs a one-way calculation. It takes your prompt and pushes it straight through its memorized rules to find an answer. This technical drawing shows how that looks in the real world. The inference server on the left holds the finished models and communicates directly with the apps on our phones to send back responses. Because the model isn't studying or double-checking itself anymore, this calculation takes just milliseconds, even though the training took months. Inference is the lightning-fast moment where the machine does the job it was trained to do. Since these two phases are totally separate, engineers have to solve two completely different problems. Training is limited by how much data a computer can process at once, but inference is limited by how fast it can answer a person who doesn't want to wait. This creates a major problem. Our world is constantly changing. New facts, new people, and new events happen every day. But as we saw, a deployed AI model has a memory that is frozen in time. Eventually, the real world shifts so much that the AI's frozen memory becomes outdated. It starts giving answers based on how the world looked months or years ago, rather than how it looks right now. This flowchart shows how engineers fix this. Look at the bottom loop. They have to collect new data from the real world and feed it back into the model improvement stage to start the training process all over again. The ultimate goal for an AI engineer is a constant balancing act, keeping the system fast enough for daily use, while making sure its frozen memory doesn't become completely obsolete. AI relies on months of grueling, expensive training to create the seamless illusion of instant intelligence exactly when you need it.